Hello, my name is Keith Wolfson and welcome to this module which I've called The Future of Technology. This course is different and it's related to these two slides that I'm going to show you. So the first one is this one here, statement by Elon Musk. And there Elon Musk is saying the pace of progress in artificial intelligence is incredibly fast. Unless you have direct exposure to groups like Google's DeepMind, you have no idea how fast it is growing at a pace close to exponential. But he is an extraordinary man. He knows about this stuff, and that's what he's saying about artificial intelligence. It is growing exponentially. And this next quote, this is Professor Rose Lucan, and she was asked to appear at the UK government's committee to investigate the future of technology in Britain and education for it. And there what she told them was that the school curriculum needs to be brought up to date to reflect that we now live in a world where problem solving and creativity are becoming more important assets. That's already the case. She said, regurgitating knowledge is something that you can automate very easily. We're seeing that now simply in the artificial intelligence that you're using with Android and with Siri, where you just start it up and you say, tell me who won the World Series in the USA in 1975 and what's the difference in scores. Now I don't need to know that at all. I don't know why it jumped into my head, but you will get an answer to that. That is knowledge, I guess. And computers are far better than us already at providing that. So she says it's something you can automate very easily. That does not prepare children for the modern workforce. Instead, she said, pupils should be spending more time working on problems collaboratively, because in future many professionals will be required to collaborate with robots. That's an interesting point. Do we have to fear robots? Many people say no, we'll just be using them to enhance the work that we're doing. But you need to know how to work with them. And they need to be taught the basics of artificial intelligence. I'm not sure about that, but what she said is, I have a horrible feeling that it's all going to suddenly become apparent that we should have been doing things differently. If you go back to what Elon Musk said, the time frame he said is 5 to 10 years, which sounds impossible. So the next few slides actually show you what your syllabus requires you to do in terms of the knowledge of future technology. This is catered for syllabus content directly addressed by this module. And there we have it in year 1. Design and produce an environment to cater for the needs of a living thing. For example, encourage the growth of a plant, e.g. greenhouses and hydroponics. So what you'll see in this is actually the future of greenhouses, the future of hydroponics. And actually, the future is here now. You'll see companies doing these things, and your students will want to know how to include that, because there's no point now in designing a greenhouse that is suitable for the British Botanical Gardens in 1999. That's in this video. Recognize that people use science and technology in their daily lives, including when caring for their environment and living things. So you'll see exactly that. A wonderful video of drones actually planting trees in a devastated environment. What would have taken people years and years to do, drones can now do in a week. Your students will want to know that. Investigate ways people use scientific and technological knowledge and skills to sustainably grow plants and animals and to produce fiber for clothing and or shelter. All of that, you'll find examples here. Plan and implement strategies considering conservation of resources to address sustainability and to meet personal and or community needs. Conservation of resources, and then identify a variety of uses for digital systems. Well, all of this is that. So that's year 1. This huge amount of resources actually just for year 1. Let's have a look at year 2. Investigate and compare advancing technologies used in food and fiber production in Australian agriculture and those used in traditional agriculture. For example, automated farming using microcontrollers and sensors compared to animal-drawn equipment, or autonomous vehicles to harvest crops compared to manual harvesting processes. Identify the roles of people working in science and technology occupations. Well, that one actually allows you to go far broader than the agricultural area, and everything in this video relates to that one. Investigate how forces and materials interact in a product or system to perform a function. And it says investigate how they interact. In other words, it wants us to look at the present, not how they used to interact. So everything in this video that shows you how these things are being done fits into that area. Investigate digital and information systems and explore how they meet personal, school, or community needs. There's a lot of that in here as well. Let's have a look at year 3. Here is the content for stage 3 that involves the future of technology. First one, investigate ways that advances in science and technology have assisted people to plan for and manage natural disasters to minimize their effect. Understand that scientific and technical knowledge is used to solve problems and inform personal and community decisions. Explore examples of managed environments used to produce food and fiber. Investigate how and why food and fiber are produced in managed environments. Investigate how people in design and technological occupations address considerations, including sustainability, in the design of products, services, and environments for current and future use. And investigate ways that advances in science and technology have assisted people to plan for and manage natural disasters to minimize their effect. This video contains resources that you would have to have at your disposal when you're covering these things in the syllabus. Our story starts in April 2016.
A computer program beat a human brain at the ancient Chinese board game of Go. The final score 4-1, a triumph for artificial intelligence equipped with human intuition.
The victory of a program over a human in the ancient board game Go has sparked intrigue and, in some cases, concern. It shows that a machine has approximated human intuition and outsmarted the best human brain in the game. It's something that scientists hadn't expected to happen for at least another decade, and it's a giant leap for artificial intelligence, showing that machines can learn on their own.
This was the moment a computer called AlphaGo beat a master of the ancient Chinese game Go. It's not the first time a grandmaster's been humbled by a machine. But what makes AlphaGo different is that it's the first demonstration that machines can truly learn and think in a human way.
AlphaGo used reinforcement learning and neural networks to mimic the learning process of a human brain. Keep in mind that the ancient Chinese game Go has as many more possible moves than chess as there are atoms in the entire universe. So there's no way of just calculating every possible move on the board. That's practically impossible.
So the way we start off training AlphaGo is by showing it 100,000 games that strong amateurs have played that we've downloaded from the internet. And we first initially get AlphaGo to mimic the human player. But of course, ultimately, we would like AlphaGo to be stronger than human amateurs and compete with the top professionals. So the way we do that is, after we take that first version that's learnt to mimic human play, we then allow it to play itself 30 million times on our servers, and using reinforcement learning, the system learns to improve itself incrementally through avoiding its errors. and increasing and improving its win rate against older versions of itself. And after all these games, then you end up with a new version that can beat the old version, the original version, around 80–90% of the time.
Technically, the reinforcement that DeepMind uses is model-free, meaning that it doesn't need a structure or set of rules to learn. According to MIT's take on the Google algorithm, the neural network, in theory, should be able to access an external memory in a manner that mimics the short-term memory of the human brain. In a way, it almost seems like our brain's design might be the most efficient way for the creation of local intelligence. Who would have guessed? So that's all good. What about this general purpose term? What does that actually mean? Well, because the machine learns from raw experience and data, it can perform well across a wide variety of tasks, straight out of the box. Okay, so that's enough talk. Let's watch the system in action, learning how to play Breakout. And remember, the machine didn't have any foreknowledge as to what task it was going to complete. It had to figure out how to do everything only from its own experience.
Is the machine before training. So this is literally the first time the machine has ever seen this data stream, and it's controlling the green rocket here, and you can see it's losing its 3 lives immediately. So it's basically terrible at the game, as you would expect. Now after training, this is like overnight, we leave it playing the game overnight on a normal computer, so for about 8 hours. You come back in the morning, and now it's superhuman level. So now the machine can play Space Invaders better than any human can. It's modeled the world, the game world so well, it knows where the Space Invaders will be ahead of time. So as the Space Invaders speed up, when you get less of them on the screen, it fires the final shot as a kind of predictive shot of where the final Space Invader will be in a few seconds.
So what could general purpose AI be used for?
We'd love to use these types of algorithms for things like healthcare and science, and improve the speed of breakthroughs in those areas by helping human experts achieve more.
In a number of interviews, Dennis has talked about applications in healthcare, smartphone assistance, and robotics as possible applications for general AI. Some other applications of such AI include online customer service, computer vision, finance, general computer science, and news publishing and writing.
how many of you are creatives? Designers, engineers, entrepreneurs, artists, or maybe you just have a really big imagination? Show of hands. Okay, that's most of you. I have some news for us creatives. Over the course of the next 20 years, more will change around the way we do our work than has happened in the last 2000. In fact, I think we're at the dawn of a new age in human history. Now, there have been 4 major historical eras defined by the way we work. The hunter-gatherer age lasted several million years. And then the agricultural age lasted several thousand years. The industrial age lasted a couple of centuries. And now the information age has lasted just a few decades. And now today, we're on the cusp of our next great era as a species. Welcome to the augmented age. In this new era, your natural human capabilities are going to be augmented by computational systems that help you think, robotic systems that help you make, and digital nervous system that connects you to the world far beyond your natural senses. Generative design tools use a computer and algorithms to synthesize geometry, to come up with new designs all by themselves. All it needs are your goals and your constraints. I'll give you an example. In the case of this aerial drone chassis, all you would need to do is tell it something like it has 4 propellers, you want it to be as lightweight as possible, and you need it to be aerodynamically efficient. And then what the computer does is it explores the entire solution space. Every single possibility that solves and meets your criteria. Millions of them. It takes big computers to do this. But it comes back to us with designs that we, by ourselves, never could have imagined. And the computer is coming up with this stuff all by itself. No one ever drew anything, and it started completely from scratch. And by the way, it's no accident that the drone body looks just like the pelvis of a flying squirrel. It's because the algorithms are designed to work the same way that evolution does. Now what's exciting is we're starting to see this technology out in the real world. We've been working with Airbus for a couple of years on this concept plane for the future. Now it's a ways out still, but just recently we used a generative design AI to come up with this. This is a 3D printed cabin partition that's been designed by a computer. It's stronger than the original, yet half the weight. And it'll be flying in the Airbus A320 later this year. That's what I'm talking about, technology amplifying our cognitive abilities so we can imagine and design things that we were simply out of our reach as plain old unaugmented humans. So what about making all of this crazy new stuff that we're going to invent and design? I think the era of human augmentation is just as much about the physical world as it is about the virtual intellectual realm. So how will technology augment us? In the physical world, robotic systems. Okay, there's certainly a fear that robots are going to take jobs away from humans, and that is true in certain sectors. But I'm much more interested in this idea that humans and robots working together are going to augment each other and start to inhabit a new space. This is our applied research lab in San Francisco, where one of our areas of focus is advanced robotics, specifically human-robot collaboration. And this is Bishop, one of our robots. And as an experiment, we set it up to help a person working in construction doing repetitive tasks. Tasks like cutting out holes for outlets or light switches in drywall. So Bishop's human partner can tell him what to do in plain English and with simple gestures, kind of like talking to a dog, and then Bishop executes on those instructions with perfect precision. We're using the human for what the human is good at, right? Awareness, perception, and decision-making, and we're using the robot for what it's good at, precision and repetitiveness.
Meet Sawyer, the revolutionary new high-performance collaborative robot from Rethink Robotics, designed to execute machine tending, circuit board testing and other precise tasks that are impractical to automate with conventional robots. Sawyer gives manufacturers the high-performance automation they need for a wider range of tasks, while maintaining the critical flexibility, safety and interactive user experience that is necessary for working successfully alongside, and with, people. Sawyer weighs only 19 kilograms, with a 1.4-meter reach, that can maneuver into the tight spaces and varied alignments of work cells designed for humans.
I'm Justin Sanchez, Director of DARPA's Biological Technologies Office. Today, I'm really excited to share with you new results on how we are working to directly interface machines with the human brain. A DARPA-funded research team led by the University of Pittsburgh has demonstrated for the first time ever in humans the experience of the sensation of touch through a robotic prosthetic arm connected directly to the brain. The volunteer, whose name is Nathan, underwent a surgery to have 2 microelectrode arrays placed in his sensory cortex. This is the region of the brain responsible for identifying tactile sensations such as pressure. Those electrodes were then connected by wires to a robotic hand and arm fitted with tactile sensors in its fingers.
Index, ring.
What you're seeing as the trials take place is that as the researcher applies light pressure to the robotic fingers, those physical sensations are converted into electrical signals that are fed directly back into Nathan's brain. Through this brain-machine interface, electrical signals are delivered as precise stimulation that his brain interprets as though his own fingers are being touched.
Index, index, ring.
Despite being blindfolded, Nathan can identify with nearly 100% accuracy
Pinky,
which fingers on the robotic hand are being touched.
20 out of 20.
What does this mean for the future of neurotechnology? DARPA has previously shown that a brain interface can be used to direct the movements of a robotic arm. Now, with this new development of adding sensation by directly sending signals from the robotic hand back into the brain, we have closed the loop between human and machine. At DARPA, we are always pushing the boundaries on what is possible. We view neurotechnology as one of the next great frontiers, enabling new ways for humans to interact with each other and with the world.
So one of the great things about the robots is that they don't really get tired and they don't really care what hours they work. And so as long as they've got juice in the batteries, they can keep going.
Right now, fresh produce really isn't all that fresh. It's traveling on average 2,000 miles from farm to grocery store. we're going to need to double the food production in the next 30 years to feed the growing population, we felt there needs to be a radical change. We're able to do the equivalent of 30 acres of outdoor farming in just a single acre of our robotic farm.
By dividing the plant's life cycle into 3 main sections, we're able to optimize the density in the farm, and each stage of the plant's life, it requires different spacing and inputs like light and fertilizer.
So it's not just that the robots can move plants around very efficiently, it's also that they can help you avoid ever having a plant go bad.
As technology replaces old jobs, it's also creating new ones. I'm Aki Ito, and I'm here to show you the jobs of the future.
My name is Katie Morich, and I'm a vertical farmer.
Katie works for a 3-year-old startup called Bowery. Its farm is here, in this industrial park in New Jersey. It's the last place you'd expect to find any sign of life. Trays of produce are vertically stacked to save space, and each of them is given just the right amount of light, water, and nutrients at the optimal temperature and humidity. It's an incredible level of precision, which is why Katie can grow more faster with less water and no pesticides. It's also what lets her grow things that taste like nothing you've ever had before.
What's this? This is the sorrel. That tastes like candy apple.
Whoa! It's so
right?
sour.
I know.
The majority of this facility is automated. The data is collected by sensors, and a computer controls growing conditions for the crops. For the things that the machines can't do yet, Katie and her fellow human farmers fill in. And even those tasks are dictated by the software that runs this whole operation.
It lets me know what I have to do, what time I should be doing it by, and that's how I get my day done.
Do you ever rebel against the computer's orders?
Once in a while, if we're trying to do a little experiment of our own, be like, okay, is this system telling us the correct thing? Most of the time it is. All the time it's right.
But no matter how high-tech all this gets, Katie thinks there will still be a place for her.
I just think there's something about the human mind that you can't really replicate. So I think we can still work closely with technology, but I still think it's nice, to have a human there. It's also be pretty lonely for the robots if they don't have anybody to talk to.
Introducing the Tron Transition Drone from Germany's Quantum Systems. This highly advanced 14-kilogram aircraft combines the long-range efficiency of a fixed-wing UAV with the vertical takeoff ability of a copter drone. This eliminates the need for a runway, additional equipment, or a human or mechanical catapult. Requiring very little ground space, Tron's 4 electrically driven propellers lift it vertically into the air toward the direction of its destination. Shortly afterward, the Tron enters the transition phase. Its forward propellers swing down to the vertical position for forward flight, while the rear propellers swing back and close into rear-facing points. Once in cruise flight mode, the Tron can travel 160 kilometers at speeds up to 80 kilometers per hour between 70 and 120 minutes. With applications that include precision farming, site inspection, 3D mapping, or delivering up to 2 kilograms of needed medical or other supplies, the Quantum Tron Transition Drone provides an effective, emission-free solution for the future. Another drone using a similar system to the Quantum Tron is the AeroVironment Quantix. The Quantix uses its 4 propellers to take off nose up, like a missile or rocket. Shortly after takeoff, the propellers reposition for horizontal flight as a fixed-wing aircraft. Upon landing, the Quantix transitions back to quadcopter configuration for a vertical touchdown, nose pointed to the sky. While that is truly awesome, the Quantix mission is what really makes it noteworthy. In years to come, food production will need to double to keep up with the growing population. Quantix's array of sensors can help farmers pinpoint the need of their crops far more efficiently, allowing for greater food production. Birds of prey have always had a monopoly on swooping in to grab something and carrying it away. Not anymore. Now technology has finally caught up with nature with this Claude creation, the robot arm drone, from Japanese company ProDrone. Thought to be the first large-format drone equipped with 2 internally developed robotic arms, the robot arm drone was developed to address the increasingly strong demand for drones that can perform specific hands-on operations. Added to an existing PD-6B-AW drone, these 5-axis arms provide an incredible amount of versatility. Because it's able to carry up to 22 pounds for 30 minutes, the developers envision a wide range of uses for this groundbreaking creation. These include carrying cargo, retrieving hazardous materials, cutting cables, and much more.
Rwanda is known as the land of 1,000 hills.
It is a very difficult country in terms of topography, and many areas are hard to reach.
Traversing that terrain to get to a rural village can take hours, even though it's a very short distance.
Today, if a mother is giving birth and suffers from postpartum hemorrhaging, her life is dependent on getting a blood transfusion.
There are many different types of blood types. They have a limited shelf life. And the challenge is when you need blood, you need it immediately. But it is unpredictable which geography that will occur in.
Hospitals that are in more remote areas can have a very hard time getting enough reliably supplied blood.
The time to order and get the supplies by truck is just too late.
There's no way that we can overcome the time that it takes to get anywhere during the rainy season. And people would say, okay, during the rainy season, we're just not going to make it.
The best case scenario, it would take at least 4 hours. But with Zipline, we are looking at cutting that 4 hours to something like 15 minutes.
It is a team of Rwandese who came together with Zipline to groom the project and to make it happen in Rwanda.
Their ultimate vision is to put each and every one of those 11 million citizens within a 15 to 35-minute delivery of any essential medical product that they could need. And that's a revolutionary idea for any country in the world.
The use of drones to deliver life-saving medical products can overcome the lack of road infrastructure. We need to let our imagination soar.
When you have a commodity, rare in supply, that might be an unusual blood type or something like a rabies vaccine, and you need it immediately, the idea that we could use a drone to be able to deliver this to the country is absolutely brilliant. There's nothing else that could do that in that way.
It is like we will no longer go around hills, but we fly over the hills.
We've pulled together a team from places like Boeing, SpaceX, Google, Lockheed Martin.
And it's an honor for Zipline to partner with the government of Rwanda.
We place a hub next to an existing medical warehouse, and it instantly enables that warehouse to make hundreds of deliveries per day to any location within range.
The doctor sends us their order by text, by phone call, whatever's convenient.
Somebody identifies the need and then prepares the package, puts it on the drone.
Then we take that vehicle and we put it through pre-flight tests. It's launched, it flies automatically out to the clinic.
The path has been already calculated, it's in the computer.
And then they'll receive a text message saying, Zip is 2 minutes away, please walk outside.
It drops the packet, somebody goes and collects it.
It turns around, it flies home, and then we get it ready for the next delivery.
Our service not only makes it possible, but also affordable for countries to deliver reliable access to essential medicines for all of their citizens.
What we are looking forward to see here is saving lives.
This isn't a small step forward. This is a transformational change to how we provide medical care to people across the world.
Half of Malawi was hit by the worst floods on record in 2015. Over 1 million people were affected. Almost 300 people were killed or went missing, and more than 370,000 were displaced. Floods are a constant threat in Malawi. Over the past 6 months, almost 100,000 people have been affected by meteorological disasters.
One big part of our work has been supporting the community, creating local civil protection committees.
The NGO is using drones to create a database indicating vulnerabilities and hazards in Mangochi and Nsanje, two districts with the highest flood potentials in Malawi. The project will end up mapping 16,000 hectares.
The drone has been collecting thousands of images, something in the range of 40,000 images. And it's also been collecting points which are used to look at the topography of the area.
These detailed maps allow residents to visualize their community in one go. Chapala villages were asked to locate their houses, potential shelters and evacuation routes.
We get the knowledge from the community, which is essential because you need to have the local knowledge to work out where things are for their village, what's important in their village, and what their understanding is of the hazards and the risks.
In this region, where natural disasters occur regularly, the EU is helping the population at a community and national level to be more prepared.
Inside this lab at Carnegie Mellon University, researchers are working on a range of drones, some as small as this one. They're designed to go into places too dangerous for people.
The idea is that in an earthquake, after earthquake or after a fire, you want to inspect a building. These places are very dangerous for a rescuer to go in, so we don't want to just blindly send people inside these places. We're going to send these things in instead.
The disaster drones will be deployed in swarms. The large drone on the table will drop the smaller drones, which will fly inside of a building, map it out, and see if there are people inside who need help. This information will be relayed back to emergency workers. The small drones carry a few sensors to keep them as small and light as possible. They have a gyroscope, compass, accelerometer, and radio. Having fewer sensors doesn't matter as much in a swarm, since they're working together as a team and communicating with each other over radio.
These things can fly into a wall, and because they're so light, they're so non-fragile, they're going to be able to hit that wall and nothing happened to them. But it's going to know where that wall is, and it's going to tell the rest system where that wall is.
The larger drone is called the mothership. It's better at handling conditions outside, like wind and rain. It also has more advanced sensors and electronics.
There's two radios. One radio gave us the camera feed, so we can see what's going on.
Oh, so
there's a camera right up here. And another radio that gave us telemetry.
Zhang says it will be 5 to 10 years before these disaster drones are in the hands of rescue workers, law enforcement, and the military.
The emergency responders see this as a gold mine. If a site goes down and you have people trapped, they have cell phones, but they can't use them because if there's a problem with the local tower, you can bring this drone in and bring connectivity, and we all know how helpful that can be for rescue workers.
We would provide our flying cow to the first responders, to say the fire department, and we would pilot it for them. So all it takes is them to place a phone call, email, contact us, and we'll provide that service.
So as computers are going to augment our ability to imagine and design new stuff, robotic systems are going to help us build and make things that we've never been able to make before. But what about our ability to sense and control these things? What about a nervous system for the things that we make? Our nervous system, the human nervous system, tells us everything that's going on around us. But the nervous system of the things we make is rudimentary at best. For instance, a car doesn't tell the city's public works department that it just hit a pothole at the corner of Broadway and Morrison. A building doesn't tell its designers whether or not the people inside like being there. And the toy manufacturer doesn't know if a toy is actually being played with, how and where, and whether or not it's any fun. Look, I'm sure that the designers imagined this lifestyle for Barbie when they designed her, right? But what if it turns out that Barbie's actually really lonely? If the designers had known what was really happening in the real world with their designs, the road, the building, and Barbie, they could have used that knowledge to create an experience that was better for the user. Now, what's missing is a nervous system connecting us to all of the things that we design, make, and use. What if all of you had that kind of information flowing to you from the things you create in the real world? The good news is we're working on digital nervous systems that connect us to the things we design. We're working on one project with a couple of guys down in Los Angeles called the Bandito Brothers and their team. And one of the things these guys do is build insane cars that do absolutely insane things. These guys are crazy, in the best way. And what we're doing with them is taking a traditional race car chassis and giving it a nervous system. So we instrumented it with dozens of sensors. And then we put a world-class driver behind the wheel, took it out to the desert, and drove the hell out of it for a week. And the car's nervous system captured everything that was happening to the car. We captured 4 billion data points, all of the forces that it was subjected to. And then we did something crazy. We took all of that data and plugged it into a generative design AI that we call Dreamcatcher. So what do you get when you give a design tool a nervous system and you ask it to build you the ultimate car chassis? You get this. This is something that a human could never have designed, except a human did design this. But it was a human that was augmented by a generative design AI, a digital nervous system, and robots that can actually fabricate something like this. So if this is the future, the augmented age, and we're going to be augmented cognitively, physically, and perceptually, what will that look like? Thanks to our augmented capabilities, our world is going to change dramatically. We're going to have a world with more variety, more connectedness, more dynamism, more complexity, more adaptability, and, of course, more beauty. The shape of things to come will be unlike anything we've ever seen before. Why? Because what will be shaping those things is this new partnership between technology, nature, and humanity. That, to me, is a future well worth looking forward to. Thank you all so much.
Finally tonight, a story about a young girl who's been given the gift of play. Ella Morton was born without bones in one of her hands. A traditional prosthetic hand would have cost up to $10,000. But thanks to one organization, Ella can play just like her sisters at no cost to her family. The story was produced by Mary Williams, a Gwen Ifill Legacy Fellow from Hughes STEM High School in Cincinnati, Ohio.
Advanced technology is changing the way we all live our lives. But for 4-year-old Ella Morton and her mother, Heather, it has made a huge difference. Thanks to some engineering students and a 3-dimensional printer at the University of Cincinnati, Ella is able to enjoy the same activities as most children her age.
When Ella was born, she has no fingers. She has no bones in the palm of her hand. She has bones up to her wrist, and she can flex at her wrist, but that's pretty much where her bones stop. She's always been very outgoing and doesn't let anything stop her.
So Ella, what do you call your special hand?
Lucky Fan, because me and Mom have a lucky fan like me.
Eden Barkis, Jacob Granger, and Deshaun Anand are engineering students and members of Enable UC, a student group collaborating with Enable, an open-source organization that provides a variety of cost-effective prosthetic assistive devices.
One of Enable UC's main missions is to provide 3D printed prosthetics for children. Prosthetics are very expensive, and children grow at a rapid rate.
This is the second hand we've given Ella. And so if she was buying a
a fully commercial, fully marketed prosthetic, every 2 years you're going to need a new hand, and where we can just be like, oh, yeah, we'll just print you off another one.
Biggest thing is getting the right measurements of the patient and understanding the mechanics of a patient, because each patient's a little bit different, and how they use their hand and how they hope to use their hand are all, different variables you have to take into account.
It's incredible that we can give someone a prosthetic and give them the opportunity to have full function in both hands.
Ella, I will say, is probably my favorite. I mean, you could tell she lit up when we gave her this hand, and she was able to, catch a tennis ball for the first time ever, which is pretty amazing.
Ella's mother says her daughter can do so much more now that she has 2 hands.
I don't think they totally get how much of an impact they made on our family and Ella. The first thing that she's always said when she puts it on, she's like, look, I have 2 hands now, Mommy, just like my sisters, and I can hold both Barbies, and I can play, and I can do all the same things as my sisters do. Or I like to think that we've never made her feel different, but this just makes it feel more normal.
For PBS NewsHour Student Reporting Labs, I'm Mary Williams.